Welcome to this deep dive, everyone. Today we're getting into something really crucial in the tech world, cyber range platforms.
That's right. Specifically, we'll be comparing two big open source players, Proxmox VE and OpenNebula.
And we're doing this deep dive with support from Stonefly. They were, the original innovators in this space, focusing on high-performing, always available IT infrastructure.
Absolutely. Stonefly's StoneFusion operating system is pretty central to what they do.
Yeah.
It helps businesses manage their important data smoothly, whether it's in the cloud, on premises, or a mix.
They offer a whole suite of things too, right? Like cloud configuration for backup and DR.
Yeah, and scalable storage for different data types, block, file, object storage, plus really robust backup and disaster recovery appliances built for today's challenges.
And I think what's really relevant, especially with our topic today, is their focus on security. Things like air-gapped vaults and immutable storage.
Definitely key against threats like ransomware. They also have solutions tailored for remote workforces, keeping things secure and efficient.
So if you're looking to make your data work harder for you with a resilient setup, check out Stonefly's resources. They've got webinars, white papers, case studies, lots to learn there.
Good stuff.
Okay, so back to cyber ranges. Let's start with the basics. What exactly is a cyber range? Why should we care?
Well, think of it as a sophisticated virtual playground. It's a complex network environment built specifically to simulate real-world cybersecurity situations.
Okay, so not just a simple test network.
No, much more than that. It's designed to mimic the complexities you'd actually face. You can run anything from, say, small penetration tests to really full-scale cyber attack simulations.
So it's a safe place to practice fighting digital fires, essentially, like a flight simulator, but for cybersecurity folks.
That's a great way to put it. It's absolutely critical for training cyber defense skills and even offensive skills in a controlled setting where mistakes don't cause real damage.
Makes sense. You can't really afford to learn on the job when a real attack hits.
Exactly. It builds muscle memory, tests procedures, and helps teams understand how to respond under pressure. It's really a key part of an organization's overall cybersecurity resilience strategy.
And for places like schools or training centers, ease of use and getting those virtual machines integrated must be pretty important too.
Vitally important.
Yeah.
Especially in education, you need something that doesn't add unnecessary hurdles to the learning process itself.
Right. So one of the main goals we're looking at today is comparing Proxmox and OpenNebula specifically for that kind of educational use, finding the best fit for, say, a military academy setting.
Precisely. The core objective was to figure out which platform makes it easier to create these realistic cyber ranges for students, focusing on ease of use and how well they handle integrating and managing virtual machines.
The aim being to recommend the one that really boosts the learning effectiveness.
Exactly. Enhancing the whole educational experience.
Okay, so how did they actually go about comparing them? What was the method?
It started with creating the necessary virtual machines. In this case, Kali Linux and Metasploitable, which are standard tools in cybersecurity training. They were built using Oracle VirtualBox, which is pretty common.
Right. Lots of people use VirtualBox.
Then, these VMs were exported as OVA files. An OVA is basically a package deal. It contains the virtual hard disk, the settings, everything needed to run the VM.
Yeah, like a self-contained appliance file.
Exactly. The next step, and this is crucial, was converting the virtual disk files inside those OVAs, usually in VMDK format, into the QCOW2 format.
QCOW2, why that specific format?
Well, QCOW2 stands for QEMU copy on write. It's a format that's highly recommended for virtualization systems like Proxmox and OpenNebula because it's efficient, supports features like snapshots, and generally ensures the VMs work well within the cyber range.
So it's about compatibility and performance within these platforms.
Correct. Ensures functionality. After conversion, they deployed 2 instances of each OS Kali and Metasploitable onto the cyber range server to act as base templates.
Like master copies.
Precisely. And then, to give access to students, these templates were cloned. They created 20 instances of each VM from these templates.
Wow, okay, so you have the master and then you just replicate it for each student.
Exactly. And the evaluation then looked at how easy this whole process was, the performance of the VMs, and how well each platform handled the resources needed for all those running instances in an educational context.
Makes sense. All right, let's dive into the first contender, Proxmox VE. Give us the overview.
Okay, Proxmox VE, the VE stands for Virtual Environment, is a very popular open source server virtualization platform. It's known for being versatile and relatively simple to manage.
And it combines 2 different technologies, right? KVM and LXC.
That's a key feature. It integrates KVM, which provides full hardware virtualization, basically. Each VM runs its own isolated operating system, almost like a separate physical machine. Great for running different OSs or needing strong isolation.
Near native performance, I hear?
Pretty close, yes. And then it also integrates LXC, which is Linux containers. This is OS-level virtualization. Containers share the host system's kernel, making them much lighter weight than full VMs.
Less overhead, faster boot times, good for things like microservices.
Exactly. Less resource-intensive, quicker to spin up. So Proxmox gives you the choice. Need full isolation and compatibility, use KVM. Need efficiency and density, use LXC, all managed through one interface.
That flexibility seems pretty useful for building varied cyber range scenarios. How easy is it to get started with Proxmox, installation-wise?
Installation is generally considered quite straightforward. You download the ISO image, create a bootable USB drive using a tool like Rufus.
Standard stuff.
Right. Then you boot from the USB, configure your BIOS or UEFI settings, making sure virtualization support like Intel VTX or AMD V is enabled,
Yeah.
setting the boot order.
Also standard server setup.
Yeah. And then there's a step-by-step guided installer. Once it's done, you configure the network, and then you can access the whole thing through a web browser interface. Pretty neat.
That web interface sounds central. What about managing multiple servers? Clustering.
Proxmox has robust clustering capabilities. You can group multiple Proxmox servers nodes together so they act like a single entity. This is huge for improving availability and performance.
So if one server goes down,
The VMs or containers running on it can be automatically restarted on another available server in the cluster. That's the high availability feature.
critical for keeping a training environment running smoothly.
Absolutely. And it's all managed from that central web interface. You can oversee all the nodes, manage resources across the cluster.
And you mentioned live migration.
Yes, another key cluster feature. You can move running VMs or containers from one physical server to another without any downtime or service interruption. Really useful for maintenance or just balancing the load.
So to make HA work, you need to define settings for each VM, like failover priority.
Correct. And you also typically need shared storage that all nodes in the cluster can access.
Let's talk about storage then. What are the options with Proxmox?
Proxmox is quite flexible here. You have local storage using the hard disks or SSDs directly inside each server. Fast access, simple setup. You can use LVM, the logical volume manager, on top of local disks for more flexibility, like resizing volumes or creating snapshots easily.
Okay, but for clustering and features like live migration, you need shared storage, right?
Yes. NFS Network File System is a common option for shared storage. Relatively easy to set up if you have an existing NFS server.
And the other big one mentioned is Ceph.
Ceph is a distributed storage system that integrates really well with Proxmox. It pools storage from multiple servers into one highly available, scalable storage system. It replicates data across nodes, so there's no single point of failure.
Sounds powerful, but maybe more complex than NFS.
Generally, yes.
That's
Ceph
not-
setup is more involved than mounting an NFS share, but it offers significant advantages in performance, scalability, and resilience, especially for larger clusters. It handles data replication and self-healing.
So NFS is simpler, maybe a single point of failure risk, while Ceph is distributed, highly available, but more complex.
That's a good summary of the trade-offs.
Okay, back to that web interface. We know it manages clusters. What about managing the VMs and containers themselves, creating them, configuring them?
It's pretty user-friendly for most tasks. Creating a VM from an ISO file, like installing Windows or Linux from scratch, is straightforward. You just upload the ISO via the web UI.
But what about those QCOW2 files we talked about earlier, the pre-built images?
That's where it gets a little more command line heavy in Proxmox.
Yeah.
You can't just upload a QCOW2 file directly through the main GUI and say, make a VM from this.
Oh. How do you do it then?
You typically need to copy the QCOW2 file to the Proxmox server first, maybe using SEP or something similar. Then you create an empty VM through the GUI, and then use a command line tool, QM import disk, to attach that QCOW2 file as the virtual disk for the VM.
So a few extra steps involving the command line.
Yes. Though Proxmox does have a built-in shell prompt accessible right from the web interface, which is handy. So you don't necessarily need a separate SSH client.
Okay. What about cloning VMs? Making those copies for students?
Cloning is very well supported and easy through the web interface. You can quickly duplicate existing VMs. Proxmox also has good support for VM templates. You create a master VM, convert it to a template, and then you can rapidly deploy new VMs based on that template.
That sounds efficient for the educational scenario.
Very. However, automating some of the finer details, like setting up unique remote access ports, VNCSB IC for each cloned VM, or easily getting their IP addresses to share with students, That often requires writing some custom scripts.
So the core cloning is easy, but automating the post-clone configuration might need scripting.
Often, yes. The GUI gets you most of the way there, but full automation sometimes needs that extra step.
And finally, for Proxmox, what about ongoing management? Monitoring, updates.
The web UI gives you good real-time monitoring CPU, memory, network, storage usage for the host, and individual VMs containers. It simplifies applying updates too, often with minimal service impact, especially if you're using clustering and live migration.
Okay, a pretty comprehensive picture of Proxmox. Let's switch gears now to OpenNebula. What's its general philosophy?
OpenNebula, also open source, positions itself more explicitly as a platform for building and managing clouds, private, public, or hybrid clouds. Flexibility, simplicity in cloud management, and cost efficiency are its main selling points.
And we heard its installation is quite different from Proxmox.
Yes, fundamentally different in recommended architecture. While you can install Proxmox on a single machine, OpenNebula's design really pushes for a distributed setup, especially for production.
Meaning separate machines for different functions.
Exactly. Typically, you'd have a dedicated machine for the front end, the management part, separate machines acting as hypervisor nodes where the VMs actually run, and potentially separate storage infrastructure.
Well, that's separation.
It's generally favored for better performance, easier scalability. You can add more hypervisor nodes or storage independently, and potentially better security through role separation. But it does mean a more complex initial setup compared to a single server Proxmox install.
Makes sense for larger cloud-scale deployments. What about hypervisor support in OpenNebula?
This is a significant difference. OpenNebula supports multiple hypervisors. Of course, it supports KVM and LXC like Proxmox.
Would also others?
Yes. It has strong integration with VMware vCenter, so you can manage your existing vSphere environments through OpenNebula. It also offers support for Microsoft's Hyper-V, though that's perhaps less common in typical OpenNebula deployments.
So much broader hypervisor support, giving more flexibility if you have a mixed environment.
Absolutely. That's a key point of differentiation. It aims to be more of a universal cloud management layer over different virtualization technologies.
How does OpenNebula handle VM creation, configuration, and cloning, especially with those QCOW2 images?
This is an area where OpenNebula shines for usability, particularly with pre-built images. Unlike Proxmox, the OpenNebula web interface lets you directly upload a QCOW2 file and register it as an image template.
So no command line needed for importing QCOW2.
Correct, it's a GUI operation. And cloning, or instantiating VMs from these templates, is also very streamlined. OpenNebula can automatically handle configuring things like the VNCS PSBE ports for remote access and assigning IP addresses from predefined network pools.
You just tell it how many copies you want?
Pretty much. You specify the template, the network, and how many instances, and it handles the setup. That can be a significant time saver, especially in that educational context of deploying many identical VMs.
That does sound easier for that specific task. What about networking capabilities?
OpenNebula offers advanced networking features. It integrates well with technologies like Open vSwitch, OVS, which is a powerful virtual switch.
What does OVS bring to the table?
OVS allows for more sophisticated management of virtual networks, creating virtual bridges that connect VMs, potentially improving performance and network isolation compared to standard Linux bridges. It also integrates with things like VMware NSX for software-defined networking.
So potentially more powerful networking, but maybe needs more configuration.
Potentially, yes, especially setting up OVS initially compared to the default Linux bridge in Proxmox.
And storage options in OpenNebula, similar to Proxmox.
Broadly, similar support for different storage types. It works well with shared storage like NFS and GlusterFS, and also distributed storage like Ceph. It's designed to be flexible with various block and file storage backends.
How does OpenNebula handle clustering? Is it different from Proxmox's approach?
The concept is similar grouping hosts, but the implementation feels different. In Proxmox, adding nodes often implicitly creates or extends the cluster managed under one interface. In OpenNebula, creating a cluster is a more explicit action in the management interface. You define a cluster and then add hosts, hypervisor nodes, to it, associating shared storage and networks.
So more deliberate configuration steps for clusters.
Yes, it reflects its more structured cloud-centric design.
And the OpenNebula web interface, overall, what's the experience like?
It provides a comprehensive dashboard overview of your cloud resources. As mentioned, the direct QCOW2 image upload is a key usability feature. You can easily manage image templates, create VMs from them, and it also provides pretty good access to VM log information directly in the interface, which helps with troubleshooting.
Okay, let's put them side by side now. Head-to-head comparison. Installation first.
Proxmox. Generally easier, often single-server install, good for integrated solutions. OpenNebula. Designed for multi-machine, more resilient potentially for large-scale, but more complex setup.
Though Proxmox clustering adds resilience too.
Right. Proxmox offers built-in resilience even if the initial install is simpler.
Hypervisor support.
OpenNebula wins on breadth. KVM, LXC, VMware, Hyper-V offers versatility. Proxmox focuses on KVM and LXC, offering tighter integration and potentially optimized performance for those two.
So flexibility versus focused optimization.
Kind of, yeah.
The web interfaces. Both sound powerful. Key differences.
OpenNebula's direct QCOW2 upload and easier access to VM logs are notable pluses for usability in certain workflows. Proxmox's integrated terminal in the UI is a unique advantage, blending GUI management with quick command line access.
Networking setup.
Proxmox simplifies initial setup with its automatic Linux bridge creation. Easy start. OpenNebula requires manual bridge setup, like Linux Bridge or OVS, offering more flexibility for custom environments, but potentially steeper learning curve for basic setups.
And getting students connected in that educational scenario.
Both offer remote connection via no VNC in the browser. Both allow granular permissions restricting admin access, but allowing direct VM connection via VNC clients.
But Proxmox had an edge.
Yes, the ease of using scripts via its integrated shell to retrieve and distribute the connection info, IPs, VNC ports, for each student's VM seemed simpler in the Proxmox environment. Streamlines things for the instructor.
Interesting. Now, stepping outside the purely educational comparison for a moment, how are these viewed in, say, enterprise settings or by home lab users?
Well, looking at some perspectives, OpenNebula is often positioned as more enterprise-ready for large, complex cloud deployments due to its scalability, multi-tenancy features, and hybrid cloud focus. Some might see Proxmox as excellent, but perhaps with limitations at massive enterprise scale regarding certain features or ecosystem support compared to enterprise cloud platforms.
What about pricing models? Any difference there?
Yeah, OpenNebula's enterprise support is often priced per physical server, whereas Proxmox's support subscriptions are typically based on CPU sockets. That can make OpenNebula seem more cost-effective in certain hardware configurations.
And in the home lab community, people tinkering at home.
Proxmox seems extremely popular in the home lab space. You see tons of discussion about setting it up, even on modest hardware like laptops running small clusters. Its relative simplicity and all-in-one nature are attractive there. OpenNebula is also used, and sometimes its integration with things like Docker Hub is highlighted, but Proxmox often feels like the go-to for many home lab enthusiasts starting out.
Okay, bringing it all back to the educational report's conclusion then. Given all these factors, which platform came out on top for the Royal Military Academy's cyber range needs?
The conclusion was that Proxmox VE was the better fit for their specific requirements. The key reasons cited were its overall ease of use and its centralized management approach.
The simplicity of the GUI and the rich tools it offered were big factors.
Exactly. In that educational setting, minimizing complex operations while still having the power available through the GUI and the integrated command line was seen as a major advantage. It was felt that Proxmox would better enhance the learning quality and the overall educational experience for their cybersecurity training.
So Proxmox for simplicity and integrated management, OpenNebula for flexibility, scalability, and broader cloud focus.
That's a fair summary of the general leanings, yes.
Well, we've definitely unpacked a lot today on Proxmox VE and OpenNebula. We've looked at them for cyber ranges, especially in education, but also touched on those wider enterprise and home lab views.
Yeah, it's clear they both have strong points. Proxmox really nailing that ease of use and integrated feel, while OpenNebula offers that power and flexibility for bigger, more distributed setups and cloud integration.
Hopefully this deep dive, brought to you by Stonefly, has given everyone listening some valuable insights, especially if you're trying to get your head around these virtualization platforms quickly without getting totally overwhelmed.
Absolutely. Understanding how these tools can create realistic training environments is so important today. Knowing nuances between them can really help you choose the right path.
So the question for you listening is, what's most critical for your needs when managing virtual environments? Is it that Proxmox-style simplicity and integration?
Or is it the kind of flexibility and scalability you get with OpenNebula? This comparison really does highlight those different priorities.
We definitely encourage exploring them further, maybe spin them up in a lab if you can. Hands-on is often the best way to see what clicks for you.
For sure. The virtualization world keeps changing, so staying informed about the tools out there is always key.